I'm going to teach you a bit about complex numbers today. A very, very, very small amount. Just enough to understand what's going on here and get to the fractals. But hopefully it will make a bit of sense to you. Okay? Alright, so here's a new iterated sequence that I'm interested in. Okay? And I'm going to write it in a bit of a funny way. Okay? Nope, sorry. Should be a C down here. C. Okay, now, just a couple of things, right? That's a Z. I write my Zs with a dash through them because when I'm in a hurry, my Zs start to look like 2s, right? I don't know if you're the same, but, you know, particularly in an exam, I just don't bother. So I write all my Zs with dashes through them, okay? What's going on here? We usually use X in here, right? X is our kind of unknown of, it's the preferred unknown, right? We're choosing Z because we're looking at a different family of numbers, complex numbers, which the significance of it I will explain soon. Okay? Now, this C here, right, is going to be a particular number. I want to try out different values of C. Okay, so this is another number. So I'm putting two numbers into this. Okay, so for instance, let's have a look at a series like, okay, let's try this one. F of 0. Okay. Now, I'm starting with simple examples. Okay. What's going to happen here? This C is 0. Okay. So I'm always going to start from 0. I'm going to iterate and see what happens. Okay. So let's give it a go. If I start with F0 of 0, okay, what do you get? You get 0 squared plus 0, which is 0. You're like, oh, okay. Well, that means I've got 0. Now when I iterate, right, I'm going to go back to this step. I'm going to get 0 again. So I get this. This is the sequence that I get out of this, right? Okay. So you're like, okay, not very interesting. Okay, well that's fine. Yes?
How can you say that Z squared equals 0?
It's 0 squared.
Substituting 0.
Yeah.
Wait, yes? No? Yes?
There's no value for Z.
I'm making Z, I'm starting with 0. I always start with 0. Okay, so this guy in here is what I put in. Okay, so in this case, really, I should have written 0 squared plus 0 from following there. Okay, so this particular value, seems to be not very interesting. Okay, but there are other values I can throw in here. How about, for instance, let's see what happens with 1. I want you to try. Give it a go. You can tell me what you get, actually. What's our first one? 1. It's just 1. Well, actually, the first one was 0. Then you get 1, right? And then what happens after 1? 2. And then what happens? 5.
26.
5 squared plus 1 is 26. Okay, 26 squared. Okay, let's see. This is a bit harder. It'll be in the 6 or 700s? 600s? 600 and? 676 plus 1? So 677. Okay, now, I'm impressed by 26 squared, but I don't think anyone's going to do. So if you got your calculator there, I've got my calculator. 4, 5, 8. Wait, what? Plus 1? Plus 1? 331? Did you minus 1? 330? And then do I add 1?
That was with adding 1.
Oh, really? Oh.
You can't end in 0. It's 7 squared.
Oh yeah, of course. Yeah, that? Is that right?
Yeah.
Okay.
It ends with a 9.
Hold on, sorry. Okay, yeah, I see what you mean. Alright. Now, I don't know, can our calculators do the next one? Or does it get too big?
You probably be able to. You can.
Just try it. Just try it. I just want to see what happens.
You probably will.
Or your phone calculator might do you a little better, because I think it's got more digits. It's 12 digits.
Yeah.
That's what I got. 210 066 388 and I'll add 1. Yes? Okay, alright. So you're like, okay, what's happening to this? We're looking at dynamic sequences, right? Now, what you've got, we've noticed two different things here, okay? We started with what happens if, you know, we're all, our Z is always starting with 0 and then we go and go and go and go. We iterate, okay? But what we're modifying each time is this number in here. What's that C, that constant flying on the end there, okay? And what impact does it have, okay? So we have seen just two examples and they are different. The first example is what we call bounded. Okay? In other words, the terms of the sequence, they don't really go anywhere. Okay? They don't progress, they don't increase in size or anything like that. Okay? This, you might be able to guess, the numbers just sort of explode, right? So what might we call it instead of bounded?
Unbounded.
Unbounded, right, okay.
Rebounded.
There's no limit to how large these numbers get, and that makes sense, right? There's nothing that would ever make it smaller, okay, because you're squaring things and getting larger, okay. Now, here's an example of bounded, here's an example of unbounded. I would like you to try and see, right, and you can do this in a pair if you like, because you're going to be testing out some numbers. Can you generate some other numbers that will give you bounded dynamic sequences versus unbounded? Some will be bounded and some will be unbounded. Can you try and work out, is there any kind of pattern? Okay? So, work together with the people who are next to you. Here we go. I can tell you now, there are some in both categories. You should be able to find both. See if you can work out what makes it one or the other. Just to, because it got raised before, this bounded example, maybe I should have given you another example of a bounded dynamic sequence. And maybe you're about to try this one already, but look, I've got positive numbers in for C, right? There's nothing to say you have to be positive, right? For instance, let's go -1. Let's go -1, okay? So this is z² - 1, okay? So you start with 0. I reckon we can do this in our heads, right? So I stick 0 in, and what happens? You get 0² - 1, so you get -1, right? Okay, now stick that back in. You get -1 squared, which is 1, minus 1, which is 0, which is then going to, remember, because they map you from one to another, the next one's going to be -1 and then 0. So this is not the same as this, but it's still, see how it's still bounded, right? It's never going to go and skyrocket. It'll never get out of this. It's kind of locked in. Okay? So I've given you 2 bounded ones for free and 1 unbounded one. See if you can find a few more and work out what's going on.